chapter is electrochemistry. Electrochemistry. Just a minute. Okay. So this chapter is electrochemistry. This chapter electrochemistry, it is a part of the physical chemistry. So part of physical chemistry where we are dealing with conversion. Here we dealing the interconversion of chemical reactions or chemical energy to electrical energy. So interconversion of chemical energy to electrical energy. It means if we have chemical reactions and that has to be spontaneous. So for spontaneous reactions, if we have, then we use the energy which due to the energy which released due to that spontaneous, that energy we use to convert the electrical energy. So the energy which is released from spontaneous reactions, that energy we use to create the electricity. So from chemical reactions to we produce electrical energy or electricity, and this we will study in galvanic cells. So the galvanic cells, or you can say voltaic cells, we will study about of it. And the second case is if we have the electrical energy. If we have the electrical energy, with that, but we use the electrical energy to do the chemical reactions. So we use the energy which is we get from electricity, and with that energy we do the chemical reactions. So from electrical energy to chemical energy. So if we have the electrical energy, with that energy we will produce some chemical reactions, that is called conversion of electrical energy to chemical energy. So that's we will study in electrolytic cell. So electrical energy means we are using the electrical energy to produce the chemical reactions. That's why you see that lytic means breaking, and electrolytic means we are using the electricity. So you can remember like this, that if we have that electrical energy and we are producing the chemical energy or chemical reactions, on that time we are studying the electrolytic cells, because electrolytic means electricity breaking. So that's the you can remember that if we have electrical energy and if we produce the chemical energy, on the time we are studying the electrolytic cells, because electrolytic means electron means electricity, that says lytic means breaking. So by this we are doing the chemical energy. So if this is electrical to chemical, then this has to be chemical to electrical, because these two are opposite. Okay, so you can remember like this, that if we have the electrical energy and we producing to the chemical energy, then this electrolytic cells is used. Electro means you have the electricity and you using that to produce the chemical reactions. Okay, so we will discuss. First we will discuss with that electrical energy. If we have the electrical energy and if you doing the chemical reactions, then how the electrolytic cell is used and what is the functions of electrolytic cells, that we will discuss. Just a minute. So first is we will study about of the using that electrical energy, how we doing the chemical reactions. So first case we are studying that we have the electrical energy. We have the electrical energy or electricity we are having. With that, how we create the chemical reactions or how we produce the chemical reactions or chemical energy. I produce the chemical energy. So for this, what we are studying that electrolytic cell. Okay, so electrolytic cell means let I take one beaker. So let me take it down. One beaker I take. Let's say any solutions is there. Not solutions. I'm taking some electrolytes here. And obviously rods, electrode rods I put here, 2 electrode rods of same size. I take the 2 electrode rods. So some rules we can say we have to remember. Some rules, that is, let's say that electrode rod assumed to be inert until it mentioned that it is active. So first we have to first assume that electrode rods is, we have not mentioned anything, then assume that these electrode rods are inert. And if electrode rods are active, on that case this electrode rod itself do the reactions. Electrode rod itself participate in the reactions. So you assume that electrode rods are inert, so that we can do if whatever the electrolytes is present, accordingly we can do. But if electrode rod itself is active, then the reactions in the reactions electrode rods itself do the reactions. So it will be, so nothing will happen, only that electrode rod itself do all the reactions. So that's why you assume that electrode rods are inert. If not mentions, it mentions, then all reactions, if electrode rods are active, then all reaction stops, and electrode rod itself do reaction. Electrode rod itself do reactions. Okay, Okay, so this one assumptions we have to make that electrodes are inert until not mentions. So now, so we have, so for electrolytic cells, this is electrolytic cell. Electrolytic cell. So electrolytic cell means from chemical energy, so electrical energy we are producing to the chemical reactions. It means we have electrical energy or we have electricity. So using this electricity we will do the reactions. So we have electricity. So electricity means any battery I will connect. So let's say I connect a battery. From here we are getting electricity. So this is positive, this is negative. So past case, before we study this electrolytic cells details, we have to say some factors on which electrolytic cell depend. So what are the factors? Let's say it depends on the nature of electrolytes. Nature of electrolytes. It means that concentration, whether the electrolyte is concentrations or dilute. Concentration means that electrolytes huge amount is present. Dilute means water is added. Yes, and also it depends on that nature of electrode rod. So if electrode rod is active or whether electrode rod is inert. So nature of electrode rod. And so this is, let's say, electrolytes, electrode rods. Okay, so this one, so we will discuss after that. Let's discuss the different cases, then what which happen. So if I say that case 1, let's say that first is electrode rod, these are inert, electrode rods are inert, and electrolytes which we take here, electrolytes, this solution part is electrolytes. Okay, this is electrolytes. Okay, this is electrode rods, so we are studying that this electrolytes, electrode rods, if we changing, then what is happening, what happens to this electrolytic cell, that we will discuss mainly here. So this electrode rod, this is electrolytic cells. Okay, so now the electrolytes, and this wall has to be not conductive, otherwise if conduct, then if you touch, then it will make our blood is good conductivity, so we may get trouble. So you take this electrolytic, this wall of the beaker as non-conductors. Any plastic we can take. Okay, so sorry. So electrolytes, here we take that, let's say I take molten NaCl. Molten, because molten means no water is present, only NaCl is present. Okay, so in this case what will happen? So electrolytic cell means here the discharge of electrolytes will discharge of electrolyte will happen, means discharge of cations and anions will happen. Okay, and this is connected to positive, this electrode is connected to positive part of this battery, so this is positive charge, and this rod is connected to negative of the battery, so this is got negative charge, and this is called here, this is called here that anode, and this is cathode, means left side is anode and this right side electrode is cathode, or I may write here left side electrode, here is anode, and this is positive charge here, this is positive charge, and we call it anode, and anode is all like that, this is called anode, and in anode always happen oxidations, anode always oxidation, and oxidation means what? Loss of electrons, loss of electrons. Similarly, right side, right electrode is here for a negative charge because it's got negative part of the battery, and it is called here cathode, because left side, right side is always cathode, and cathode it is happen always, cathode means always reductions, always reduction, either it is electrolytic or it is electrolytic cell or carbonic cell, always happen the reductions, and we know reductions means gain of electrons. Okay, so we are studying this case that electrode is we are taking anode, and or not mentions means we assume that this is anode, so you can say that or not mention, then also you assume that is anode. Okay, so here that electrolytic cell means what? Electrolytic cells in electrolytic cell, what happened? Discharge of charges of respective ions, means in this part of electrolytic cell, what happened? The discharge of charges of respective ions, means the ions will discharge their charges, so this will happen in electrolytic cell. Okay, so if you take that molten NaCl, means only NaCl is present, then this NaCl, this is strong electrolytes, okay, this is NaCl, strong electrolytes. So strong electrolyte has the characteristics to completely dissociate. So this will dissociate into Na plus Cl minus. And now, so electrolytic cell means discharge of ions. Okay, so they will discharge their charge. So now this here it means NaCl means it present as Na plus Cl minus, because this is strong electrolyte that is completely dissociate. So Na plus Cl minus is present, and since this rod is positive, and this rod is negative, so this positive charge attracts, so this negative charge attracts towards this positive charge. So this negative charge attracts towards positive charge, and this positive charge attracts towards negative charge, and discharge will happen. Okay, so what happened? Where I will write. So it is better to write. So case 1, we are studying that electrode rod are inert and electrolyte is molten NaCl. So what I have taken, so this NaCl, the electrolytic means discharge of ions. So here NaCl we have taken, so this will strong electrolytes will dissociate into Na plus Cl minus. Okay, so we have that two rods, one is positive, another negative. So positive rods, so here positive rod is anode and negative rod is cathode. So positive rod is anode means oxidations, and cathode means reductions. So whenever this NaCl will get attracted towards oxidation, means loss of electrons, reduction means gain of electrons. Okay, so when this Na will attracted, this Cl minus attracted towards positive rods, and this so this Na plus will attracted towards this positive, so this Cl minus get attracted towards positive charge, and here the oxidation will happen and loss of electron means Cl minus do oxidation means loss of electron, means this will do what? Cl plus electron minus loss of electrons, and this Cl is not exist, so 2, so then we have to do here 2, we have also has to do 2. Okay, and one more thing you have to remember, that in electrolytic cells or anywhere, that the electrons should be same. Here 2 electron means here also you have to make the 2 electrons, and this is negative rods, so it attracted towards positive, so here Na plus, here gain of electrons, so electrolyte will gain this electron, but this is 2 electrons, so 2, so you have also 2, then write that 2Na. Okay, so this will happen if the case is electrode is inert and it is molten NaCl. Now if you study the case 2, Now in case 2, that if electrode rod will keep it now also or not mentioned, then also you have to assume. And electrolyte, now we will take NaCl aqueous. If NaCl aqueous we have taken, then what will happen? And aqueous means this is NaCl aqueous means just concentrate, not huge amount of water is added, just concentration of NaCl, but water is there. Okay, so this is, let's say, the concentration, not see, if NaCl, if you add water, then we can say that it's concentrations, means NaCl quantity is used. But if we says high amount of water added, on that cases this will become dilute. So actually you have added little amount of water, so that is concentration. On that case what will happen? Other cases, if you add high amount of water, then what will happen? The two cases we will discuss. So this is electrolytic case when you are adding the concentrations. So here we have that positive charge, positive, here we have the anode, positive charge, here we have the cathode, negative charge. Okay, so this NaCl again dissociate into this NaCl again dissociate into Na plus Cl minus. So this Cl minus get attracted towards anode because this is positive charge, Cl minus, and here oxidations will happen and here reductions. Okay, so Cl minus, what it will do? Loss of electrons. So this will Cl minus, sorry, Cl plus electron. Yes, so NaCl with that, sorry, I will do little bit clear. So here NaCl is present, electrolytes, with that water also came, so water is also there. So this NaCl will dissociate into Na plus Cl minus. Similarly this water also dissociate into H plus OH minus. So here this oxidation means positive charge will get attracted to this, but here that's negative charge are Cl minus and OH minus, both are present. So both will go to here, Cl minus and OH minus, and here negative charge means positive charge get attracted, so both will go, Na plus and H plus. Now the thing is that which will discharge, Cl minus or OH minus for case of anode, and here which will lose, which will gain electron, Na plus or H plus. So the competitions will start. If more than one is present, then obviously competition will start, which will between them which will go. Okay, so for that for these cases, that electrochemical series or SRP series, standard reduction potential series, we have to look. So this will discuss many procedures chapters. So for understanding this concept, you just remember the values. So what are the values? We have to remember, that is, remember like लिखोबा स्कूटर कार ना मांगे आलू मंजन कर पेरिस को निभाया. Okay, so this series you have to remember, or I will write so that you have to remember this series. How? Like you remember lick, or you can remember liko ba scooter car लिखोबा स्कूटर कार ना मांगे आलू मंजन कर पेरिस को निभाया. So this series you have to remember. So लिखोबा means I'm this after that this is came. Okay, so लिखोबा स्कूटर कार ना मांगे आलू मंजन कर पेरिस को निभाया. This you have to remember. And after that this H will come, and after that here from here. So what copper Hg copper silver gold platinum then F. So this we have to remember, this series. This is the SRP series. Okay, so लिखोबा स्कूटर कार ना मांगे आलू मंजन का पेरिस को निभाया means लिखोबा one car, let's say that she not ask scooter or car, but he aloo means potato, he enjoy the potatoes and peros. With peros we can say enjoy, like that we can remember. So लिखोबा स्कूटर कार ना मांगे आलू मंजन कर पेरिस को निभाया. So this you have to remember. After that H will come. After H this copper, you can remember that copper is less value copper. After that Hg, after that silver, after that gold, then platinum, then F2. So this series you have to remember. And another series for ions, that series is, let's say, copper Hg and Cl minus NO3 minus SO2 minus. This series you have to remember. Just remember Cl minus and that is Cl minus, after that OH minus, then NO3 minus, then SO2 minus. So this series you have to remember for ions, and this is for this metals. So these things you have to remember. This series you have to remember. Okay, so this you can remember. लिखोबा one car, scooter that is 2 wheelers, after that 4 wheelers, scooter car, I say not asks na mange, and potato, he enjoyed potatoes, and he went with Paros. After that we can remember like copper is less value. After that this Hg will come, and then silver, gold. Okay, silver is less price, after that gold, then platinum, then F2. So like this we can remember that electrochemical series. And this copper Ag, Cl minus, it's minus, Na3 minus, SO4 minus, this ions we have remember like this. Okay, so this chemical series we have to remember. And what that in SRP series for anode, SRP series, that above one will take this above one, which is above one, that will dominate. And for cathode, SRP series below one is dominate. Okay, so we will see. So from Cl and OH minus, this is anode. Upper anode, what above one will dominate, so which is above one, Cl minus, so Cl minus will discharge. And for cathodes, downward will dominate, so Na plus and H plus, which is downwards. So here we can assume this positive, positive, positive to positive, like that we can assume. So which is downwards, this H is downward, this is above. So this series is like this and like this, so this is so much below, and NH here and H is here, so which is downward H, so H will dominate, because in cathode SRP series downward will dominate. Okay, so I will so it is better to release the electrochemical series, so we understand this series. So I can note this one and refer this one, so I will directly use. So you take this SRP series. Okay, so I'm just erasing, otherwise writing will be a little bit difficult. So from that, for anodes, this OH minus has dominate, because we are looking the downwards. Okay, so OH minus will, what oxidation means, loss of electrons, so this will lose OH plus electron minus. But thing is that this OH is not exist. Have you seen OH? So we see that water, but OH we never see. So what happened is, we can do that OH minus. So 2OH we can do. So for 2OH we need 2OH minus. If 2OH minus means this is 2OH plus 2 electrons, and this 2OH means I can write OH plus OH, that is going to give water. Okay, water plus 1 O. Yes, this one O, and O is also not exist, so what I do, O plus O. So what I do here, 2OH, 2H, so that I can do 2H, multiply to both sides, then this 2O, then this exist as O2. Since this is 2H, then I have to do this also. How many 2H? 4OH. So this also has to be 2 and 2. Okay. And this has to be 4 electrons. So what you notice here, that this 2OH minus plus 2OH minus is going to give 4OH minus, and that it will give like this. So here the discharge is happening, right? OH minus is going to give that, but since this OH not exist, so we have to do like this. So finally it will exist as which form, so you just add it, it exists. So it actually do like this, but it not exist as 2OH, and not exist at OH, so we have to do these reactions, and if these are the primary reactions, so you have to get the stable reactions. So if you add whole, then what you will get, 2OH, this 4OH, this 4OH cancels, and this 2O cancels. So what will remain? 4OH minus 2H, 4OH minus, these all are cancelled. That going to give 2H2O plus O2 plus 4 electrons. So this is the final reactions in anode. This is the final reactions. Similarly for cathode, what happened, since we have already said that 4 electrons is used, so here also we have to do 4 electrons. So 4 electron is fixed, because you have the 4 electron means you have to also use the 4 electrons. So 4 electron is fixed, and now the competition will start Na and H plus, and for cathode downward we will look downward series, and this Na H plus is downward than Na, so we have seen the electrochemical series. So H plus will discharge, so H plus will, cathode means gain of electrons, so gain of electron will happen. How much electron it will gain? 4 electrons, means it is also become 4, then it has to give H2 to H2. Okay, or I can simply write H plus 1 gain electron, that become H, but H is not exist, that is H2. So if I 2, then the 2 and 2, but here is 4 electrons, so I have to make this 4 electrons. So for that I have to do multiplied by 2, then that will become 4H plus 4 electron, that is going to give 2H2. So this is happened in cathode. Okay, so these reactions happened in anode, these reactions will happen at cathode. So from here we can memorize that. Always you know need to calculate, so we have to memorize that for production of 1H2O, how many electrons we need? For production 1H2O we need, for 2H2 we need 4 electrons, and for 1H2 we need 2 electrons. Similarly for productions of 1 mole of H2 we need 2 electrons, for productions of 1 mole of O2 we need 4 electrons. Okay, similarly here, from here the productions of 2 mole of H2 we need 4 electrons, then productions of 1 mole of H2O, 1 mole of H2 we need 2 electrons. Okay, so from here these things we have to remember. So this was the case 2 and A, so where that H2 is in concentration, and if you add more amount of water, then that become dilute. So for that case what happened, let's see. So here is anode, anode means oxidations, Okay, oxidation means gain of loss of electrons, and here will be reductions. Reductions means gain of electrons, sorry, cathode, and this is positive charge here, this is negative charge here for this rod, and the gain of electrons. Okay, so now what happened that we have taken the NaCl same NaCl, this is the D case. NaCl same thing, electrode rod is inert, and electrolyte is NaCl, but now case we take the dilute. Okay, for that case what is happening? So this NaCl is going to give Na plus Cl minus. With that dilute means what is there with huge amount, that is H plus OH minus, but this is excess. So this also give excess, this also is in excess. So for this case what happened, for this anode what happened that both H plus positive charge and negative charge get attracted, so Cl minus and OH minus is there, this is in excess. Similarly for cathode, Na plus and H plus is there, but this H plus is in excess. And from we will study in the other class that Nernst equations. In Nernst equations, what is that E cell equal to E naught cell minus E naught cell, that is something like 0.693 2.303 RTNF, and concentration of product by, so I can write product concentrations divided by reactant concentrations. So this is the Nernst equations, and from this equations what it says that this E cell is directly proportional to the concentration. If we say that if you I just RT and NF, let me see that reactions. Log, okay, log, sorry, so log, so this is log concentration of product by concentration of reactants. So in this that if you want to remove that positive cell, this negative, then this will become E cell, then you can write plus 2.303 NF RT. This will become a concentration of reactants divided by concentration of product, means at least product and concentration. So this E cell is depend on these concentrations of product and reactant. So if concentration is very high, if it is very dilute, if any substances or any electrolytes it have high concentrations, then that it directly affect the E cell. So same manner, if that H plus concentration is very high, then E cell is also high, means it will be discharge. Similarly, this concentration is very high, then this will discharge, because that is directly proportional to E cell. Okay, so sorry, this is Cl minus and OH minus, this is excess. So this Na and H plus, here H plus is excess, so since H plus is directly proportional to E cell, so H plus will discharge, not Na plus. Yeah, okay, it may be also an electrochemical series. If you see that H plus is dominant, so H plus is favored by both the surface series and also this is excess, so E cell is also high, so it will both favor, so here H plus will discharge, so it will gain up electron, and become H2, and this is 2 and this is 2. This will be the reactions for cathode. Similarly for anode, what happened that OH minus is excess, Cl minus. So if you see that electrochemical series, that what not this is copper Ag, Cl minus, OH minus, NO3 minus, SO4, 2 minus. This is the electrochemical series. And for anodes, you have to look that above 1. So above 1 Cl minus is present, so Cl minus has to be discharged, but since this is excess, so Cl minus will not discharge, OH minus will discharge. So Cl minus SRP series dominate, and this OH minus excess, so Cl minus will not discharge, OH minus will discharge. So this will lose electron into OH minus, loss electrons. Okay, but this OH minus, OH is not exist, so we can do this. How this will be OH minus plus OH minus, that is going to give, okay, OH minus, and this OH plus OH, that is going to give water plus O, and this O plus O is going to give O2. Okay, so this will become 2, we need here 2 O2, so that we can do, so I can multiply by 2, so we need that 2O. Okay, so I have to multiply whole by 2, so I can do 2H, I will multiply by 2, so 2, so if this is 4OH, then everywhere I have to multiply by 4. Okay, so this, the final reactions will be this cancels, and this cancels, so 4OH minus going to give 2H2O plus O2. This is the final reactions. And for here, so 4 electrons we need, so I have to multiply by 2, so that will become 4H plus 4 electron, that is equal to 2H2. This is the final reactions. Okay, so if we added that excess amount of OH minus, then these reactions will happen. Whereas if we add that concentration amount, sorry, here the concentration na, so here this OH minus will not go, because for anodes Cl minus will dominate, because Cl minus which is above that will dominate. Yes, so this is wrong. Sorry. So anode oxidation. So SRP series, what the SRP series says that copper Ag Cl minus OH minus NO3 minus SO42 minus. So in this series that anode that above one will dominate. So from Cl minus, and here anode which comes Cl minus and OH minus has came, and this is concentration, so not excess. So here that above one will dominate. So above one is which is above Cl minus and OH minus. Cl minus will go, not OH. Okay, so if concentration is there, then OH minus will go. Cl minus will go, not OH minus. So Cl minus, what it will do? Cl plus electrons, so loss electron. So Cl not exist, then this electron. So if that is the concentrations, then the cell reactions is this and this. For this is for anode, this is for cathode. And if the cell reactions, if the electrolyte is dilute, then the cell reactions will be this, for this is for anode and this is for cathode. You see that if that is dilute, then for anode this will be the reactions, whereas for if it's concentration, this Cl minus will be the in anodes. Okay, for dilute OH minus will be anode. For cathodes, both cases H plus wins. So here also for cathode H plus H comes, and for here also H plus H came. So we have discussed that. Case 1 we have discussed if it is anode, and if anode, and this is molten, and we have discussed that aqueous 2 case, concentration dilute we have discussed. So this is about of the electrolytes, and next we will study about of that electrorods. If we change the electrorods, then what happened? Okay, now the case 3. Now that electrode rod says electrorods, is both electrorods are present, where one is for anode and another is for cathode. These are the two electrorods. So let's say electrodes in cathode, we have used that Hg, and for anode we have used the platinum only. And that electrolytic cell, let's say that electrolytes is, let's say I take that NaCl, molten I take, then what happened? So anode and cathode. So anode means can of electron, this is positive charge, this is negative charge here. So this NaCl, the discharge into Na plus Cl minus. So this Cl minus should come here. Cl minus will comes, and this is a loss electron, Cl plus electron. Since Cl2 exists, so 2, this is at anode. Similarly for cathodes, Na will go, Na plus and since in cathode that Hg is there, this is active electrodes, so this Na will not discharge, but it will this Na will discharge into Na plus electrons, and this Na will react with Hg and form that NaHg. Okay, if NaCl is molten, this will happen, so no problem. But another case, if NaCl is not molten, if it is aqueous, then what happens that with NaCl is going to give Na plus Cl minus. Now water is also came, so water will go H plus plus OH minus. So here in anode Cl minus also came and OH minus also came. So competition started. Similarly for cathode also, H plus H came and Na plus H came. So competitions will start. So from electrochemical series, Cl minus H dominates, so this will happen. Okay, because Cl minus has that high oxidation potential, that is above SRP series. Above is Cl minus, so Cl minus will discharge. And here in cathode in SRP series, downward, so downward, then H plus H dominate. But the problem, so H plus H dominate, then H plus should gain electron and give that H2. This should happen. But what happened that here that NaHg, this will amalgam will prepare this amalgam. And what happened that in thermodynamics we know that if anything, if that randomness is decreases, because this liquid is forming, so if a liquid is forming means that randomness is decreases, and if randomness is decreases, then that is spontaneous. So if anything is happened in the system, if it is spontaneous, then that will be dominant. So here, although in SRP series this H plus is winning, but since Na and Hg is making the amalgams, and that is decreases the spontaneous, that is decrease the randomness, which becoming the reactions in a reactions becoming spontaneous, so that will dominate. So here according to SRP series this should happen, but this will not happen, this will happen, because this is spontaneous reactions. Okay, so if you add H plus water, and if you add also water in excess, water if you add excess, then here that OH minus will come, because you have added excess, so this will become for OH minus will discharge. Okay, then we know that what the reactions is. And for here again H plus and Na plus, but H plus is excess, but still NaHg will form, because this is the spontaneous reactions. Okay, now the last case. The last case is if electrode rod is active and electrolytes like is anything we can take. Electrolyte is anything, I mean it may be NaCl aqueous, NaCl molten, or it may be NaCl aqua, that is in excess, or it may be Mg Cl2, it may be Al2Cl3, any electrolytes you take. Then what happened, since these electrorods are active, now, then what happened, this all reactions stops, since electrode are active, all reaction stops. Only electrode do the reactions. What does it mean? It says in anode oxidations happen and cathode reductions will happen. So whatever you give that in anodes, if that let's say excess is there, then what you given? Let's say you have given that NaCl. NaCl there is going to give Na plus Cl minus, and let's say aqueous excess we given, then this is H plus excess and OH minus excess is there. Okay, so in anode will come what? Na plus H plus excess, and here let's say OH minus excess and NaCl minus. Sorry. Anode is positive charge, cathode is negative charge, so negative will come, so Cl minus OH minus excess is there, and here Na plus H plus excess is there. But since that electrode is active, then what happened? That Ag minus itself do the reaction. So what happened? That electrode is active, so Ag also participate here. Okay, then this Ag itself, so let's say in competitions Ag came, okay, and in competitions Ag plus came. Okay, then what happened? This Ag will win, not this, Ag will win. So if electrode is active, then itself do reactions. So in anode, Ag itself do the reactions. That is anode means oxidations, gain of electrons. So loss of electrons is going to give Ag plus electron minus. This is happened in anode. Same time in cathode, this Ag plus will gain electron and form the Ag. So no reaction, not this, either the excess or at any amount, nothing will happen, only this Ag will do. Okay, so this is the examples of refined electroplating. So this both examples are using in electroplating. What happened there? Electroplating, what you are doing, that if you have the two rods, let's say any electrolytes you will take, any electrolyte, let's say NaCl or whatever you will take, and if you have the two batteries, they have to connect it into a battery. What happened? That what are you doing, that this is impure and electrode rods, impure, let's say you will take, suppose you are taking that gold, impure gold, and what happened that here current will flow, so this impure gold Au, what happened, this will lose electrons and form the Au2 plus 2 electrons. Okay, and what happened, this Au2 plus form, then these 2 electrons will go here and this will go here. Current will flow these sides, this is current flow, and electrons is flowing from here, and this is the another rods, this is another rod of Au. Then what happened, this Au here, Au 2 plus will accept this 2 electrons here, this AU, this rod AU, what happened, this AU give AU 2 plus and 2 electrons, and now this is another AU, this AU that will be created a positive charge and thus accept the 2 electrons and form that AU. Means with time this size of this AU increases. It means that this is cathode, this is anode. So with time this cathode, what happened, this size is increases. Means all this impure 1H get electroplating on this. Means all this gold is coming to this here, store here, and anode size decreases. Okay, so this is the applications of electroplating. And we have discussed all the cases. See, in these reactions what happened is, we are taking that NaCl, so in case 2 we have taken that NaCl and in the aqueous. Means in this reaction, in case 2 reactions, what happened, we have taken that NaCl aqueous. Means we have that NaCl and we have water. So this NaCl is going to give Na plus plus Cl minus, and this water give H plus plus OH minus. And in that reactions, in anode we are getting Cl and in cathode we are getting H. Means overall Cl and H plus is using, and NaCl is NaOH not using. So in these reactions, overall what we are preparing, this Cl minus is using by here, and H plus is using, this is using, and this is also using, this using. So remain this NaOH is not doing any reaction, so NaOH will synthesized, because this is left in the solution. So in this way we can prepare that NaOH. So synthesis of NaOH can be done. Okay, because Na and Cl we will use in these reactions that will do in cathode and anode reactions, and remaining this NaOH. So this Na and OH do reactions and form NaOH. So by using this case 2 we have prepared the NaOH. So if you NaOH, and if you see in the overall of these reactions, what happened, that Na and Cl and H is using. Means OH minus is left in the solutions. OH minus is left in the solution. Means if OH minus is left in, so if OH minus concentration is increased in the solutions, means what, pH is increases. Okay, because if OH minus concentration increases means pH increases, and if OH minus concentration decreases means pH will decreases. So here pH is increases, pH of the solutions is increasing. Similarly here, that no water is there, so pH is constant. pH of the solutions is remain constant. Okay, and for this case, if you add that aqueous excess amount of water, then what are the reactions happening? OH is using and H plus is using. It means H plus is using here, another is OH minus is using here. So both H plus and OH minus, both are consuming, means pH will remain constant, because H plus it increases, then pH will decreases, and OH minus will increases, then pH will increases. But here both H plus and OH minus are equally consuming, so pH of the solutions remain constant. And in this case 3, what the reaction Cl minus and Cl2 2 electrons, and here the reactions is this Na and Hg, it means what OH minus okay, here also OH and okay, here also when H both are consuming, means pH remain constant. So you understand that if in the solutions H plus and OH minus, it will not use, then pH will decrease or increases. So like this we can understand from here. And here another thing, that what about of that Na, here H and Cl is using, and OH is left in the solutions, and Na also left, so this Na is act as a spectator cations, so this is not using. So after that Na and OH is remaining in the solution, so we can prepare NaOH. So but NaOH is strong electrolyte, so that will give me Na plus and OH minus. So this Na also act as a spectator cations. Okay, so now the next topics, that is Faraday's law. Next topic we will look Faraday's law. Okay, so what this Faraday's law says, so if you have any solutions, it is there, like it may be any solutions, either NaCl, aqueous, whatever the solutions, and if we have that electrode rods and we have connected to a battery, then what happened, let's say this is let's say this any inert rods like platinum, then what happened, what this Faraday's law says, that past laws, that amount of mass deposited on this electrode rods, amount of mass deposited on electrode rods, amount of mass, or for gases, amount of gas liberated on electrode rod is directly proportional to the charge passing through the solutions, that means that amount of mass deposited on these electrode rods is directly proportional to that what amount of charge is passing through these solutions. Okay, so it means that how many electrons are passing through these solutions. So it means mass is directly proportional to this charge. Okay, and if you remove that proportionality constant, then I can put that Z cube, and this Z is a constant which depends on cations, nature of cations and anions. Okay, and we know that Q equal to IT, so I can put M equal to ZIT, and this Z is also equal to E by F. This is E is equivalent weight, and E is equivalent weightage, but molar by X factor. X is that number of electrons passing, means let's say for acids the number of H plus, for base number of OH minus, so that is any X factor, that number of electrons passing for electrochemistry. So you can write like this, so E equal to M by X, so I can say M equal to ZIT. So Z I can put E by F to IT. So this, so in the numericals we will use this formula. Okay, and second Faraday's laws, what it says that if you say that so if any, so my second Faraday's law is just extension of first law. What it says that if the amount of mass deposited, so first Faraday says that amount of mass deposited on this electrode is directly proportional to amount of charge is passing through the solutions. First law says M is directly proportional to Q. Second law, what it says? Second law says that if same amount of, so previously that M is directly proportional to Q for first law. Now what it says that if Q is same, the same amount of charge is passing through the solutions through these different electrolytes. Maybe this, maybe platinum, maybe this is copper. So very time means through different electrolyte is changing. So that what it says that if Q is same, if same charge is passing through the solutions, then the amount of mass deposited on this electrode rod is directly proportional to the equivalent weight of this rod. Okay, so the equivalent weight of, let's say Ag equivalent weight is different and copper Ag equivalent weight is different. So what it says that if Q is same, if same amount of current is passed, if same amount of charge is passed through these solutions through different electrolytes, maybe this platinum, maybe this is copper, then the amount of mass deposited to this electrode is directly proportional to equivalent weight of these rods. So this says that mass is directly proportional to Q from past laws. What is say that if mass, let's say if ZQ, if let's say if Q is same, if Q is same current will charge, then, or we can say from past laws, what it says M is directly proportional to Q, M equal to ZQ. So what it says that this is for, let's say, one electrolytes. Let's say this is for one electrolytes. Let's say any electrolytes. Let's say for copper electrolytes. This mass of copper, this ZQ, and mass of copper equal to Z. So Z equal to E by F. So this is for copper into Q, and another for, let's say, copper and what you take another electrolytes. So another electrodes, let's say Zn you can take. So Zn, so then let's say M Zn, that is equal to Q. Zn equal to Z by Q. Zn equal to E. E is equivalent of Zn by F Q. Now what he says that second law, what it says, Q is same, then what I said that M by Zn by M by copper equal to, I can write E Zn Q F divided by E copper by F into Q. Since Q is same, so this I will cancel and this F will cancel. So it means that M of Zn by M of Cu equal to E of Zn, E of Cu. This is the second law of Faraday's. Okay, so what the second law Faraday says that if same amount of charge is passing through the solutions, then the amount of mass deposited on this electrode is directly proportional to the equivalent weight. What are the equivalent weight of that electrodes? Okay, so today after this, tomorrow we will discuss about some terms of electrolytic cells, that is conductivity and molar conductivity. That things we will discuss in tomorrow class. So today after this, thank you.